Okay, let's see if it uses the same live stream or it creates a new one. Because if it creates a new one, then I have to update links. If it doesn't create a new one, then I'm good. I hope to God it doesn't create a new one, but well, I can only do so much, right? Whew. Latency. Alright, let's see if the class link would take you to the same. Because I need students to come to this tutorial link that I posted. No, it doesn't. Okay, since this is the case, what is the new live stream tutorial link? Ah, Son Goku. You know? I would just like to say, I hate YouTube. Copy. I need to update the link. Announcements. Edit. Oh my, this is dumb. Okay, hopefully students realize that I posted a new link. Follow it. That's truly unfortunate. But things like this happen. Perhaps I should give everyone a bit more time then to join the live stream, just because I'm going to be teaching to an empty class, and that ain't doing it for me, Chief. This is really stupid. Yo, hello. Okay, people are noticing that I updated the link. That's fine. That is good. Your current bitrate is too high. No, that's not a problem, YouTube. Don't tell me it's a problem. Les fish la vache. Very confused why I got a 6-minute video. Yeah, I changed an encoder, changed encoder setting, and that resets the entire live stream. So that's my bad. I'm gonna get started. More people. We usually don't get anyone in these tutorials anyway, so I don't feel that bad just starting. But yeah, I was trying out a new setting. I shot too high, so to speak. So let's redo this. Monty Python and the Holy Grail. Come on, how can you call yourself a computer science nerd? Monty Python. I know Monty Python and the Holy Grail. I didn't get that. What is your favorite color? Blue? No, green. Ah! Come on. It's a great. The knights who say knee. Many jokes. I'm gonna give it exactly 2 more minutes just to let people get together. I know. Ah, you're gonna make me do this. Okay, fine. You know what? Yeah, it's just to fetch the cow. When they catapult the cow over the castle wall or whatever, isn't it? Yeah, they catapult a cow. Can't remember the specifics, but clop. Okay, let's talk object-oriented. Last year, even the hardcore comp size had a massive problem with this concept. Like, proper massive problem. So I've decided to go a bit off tutorial from what is taught in the other tutorials, because basically we dive in assuming you guys mastered object-oriented, and clearly, if the hardcore comp size couldn't get it, I highly doubt people who are coming here willingly from other electives probably would thoroughly understand the concept. So I'm going to first give a overview of object-oriented, and then I'll get into some more complex examples if we have time. And you guys can basically request anything for me to code. So first, let's talk about... How do I want to word this? Let's talk about objects without having objects yet. What is an object? Well, you can think of it kind of like this, a dictionary of information. So we know that a car is a brand. This is just an example. I know nothing about cars, but cars are a really good example that people seem to understand. That don't like to be oriented. Oof. No. We're not getting there. I'm not touching that. I'm not touching that with a 10-foot pole. So you can make a object, something that you want to describe. Cars are a good example. They have a brand, some sort of model, whether it's a pickup truck or an SUV or your good old soccer mom, hardcore. Everything is an object in Python. Yes, everything is an object in Python. Files are an object. Errors are an object. Everything is an object. Oh, hey, there's my roommate. Go get surgery. Anyways, but cars, I've simplified it down to 3 simple states. This is what is called a state. It is something unique to the object, unique to the instance, but not to the object. So every car has a brand, a model, and a year, but not every car is the same brand, or the same model, or the same year. So although every car has a brand, not every car is a Ford. Some of them might be Audis. I can't name more than a GMC, Toyota. I've named 4. You guys must be so proud of me. And the issue is, what happens when you want to create more cars? Well, you're going to have to create this dictionary every single time. So Audi, they do those race cars, don't they? I don't know. So we'll say Audi makes a race car, and we'll give them a 2012 model. Then we have car 3, and car 3, not car 32, will be a Toyota SUV, kind of like my mom's 2019 Toyota Highlander. So we have 3 cars. Audi A8, that is apparently a car. I did not know. But we have 3 cars, all of which are cars. They have a brand, a model, and a year, but not all of them are the same car. Clearly, a Ford is different from an Audi, is different from a Toyota, but all of them have common traits. Another thing that cars can all do is they can all honk. I have defined this function. It takes in whatever car you want, and it simply says the car brand, space, the car model, space, says honk. So for this first one, it would be Ford pickup truck says honk. And if I call honk on all 3 of my cars, it will be different for all 3, but it's the same function, right? So if I run the code, we'll see the output. It should be Ford pickup truck says honk, followed by, and I've just remembered, I have to print this. How many of you guys were screaming that it? We have 3 cars, all of which are cars. That is so far what I have taught you in this. I know what I'm saying isn't that hard, but that's the thing. I need you guys to realize that object-oriented programming isn't that hard. So here you can see Ford pickup truck says honk, Audi race car says honk, and Toyota SUV says honk. Now this is nice and cool, but there are certain things that aren't happening. For example, what happens if I want to just print a car and I want it to return this string? Well, if I run the code and I go to print the cars, you can see it prints the dictionary. And there's no way that we can override that with normal code. Stream has disconnected. Attempting reconnect. Okay. My stream is apparently reconnected. Apparently my stream has disconnected. I'm going to make it extremely clear that my internet is extremely bad. Like, properly crap. So, yeah, luckily, I have, you guys can see Cameron McLean in the chat. He's a moderator. He's my roommate. He's watching the stream and is texting me on my phone whenever things happen. So even if I'm not paying attention, I have him. I don't know how long he's going to stick around, but he loves me, so. Anyways, but yeah, so let's turn this into a class. So I'm going to go ahead and just down here, I'm going to create a class of a car, something that defines a car. And we're very much going to copy this type of model. So the first thing we need to do is build the car variable. And how do we do that in an object? Well, car is going to be changed to self. Every car has its own information, a dictionary of its states. This is called the self dictionary. And the way we initialize this is actually using a function called init. Now, init takes in self, the self dictionary that is created, and you can pass in any variable. So I'm going to pass in a brand, a model, and a year. And what I'm going to do is I'm going to say that self. Now, normally in a dictionary, you would do self at brand. In an object, you access everything through dots. So I'm going to do self.brand equals brand, self.model equals model, and self.year equals year. That's me defining the self dictionary. I now have a dictionary with a key matching to the variables I passed in, and I've called it self. Now, let's make this honk function. Honky honk. So self, we're going to, in the class, define honk, and instead of taking in a car, it takes in the self dictionary. And all we're going to do is we're going to do the exact same thing that we did here, but we're going to translate the dictionary notation to car notation. So what do? Well, like I said, it's self at brand. However, there's no index brand, it's self.brand. Same thing here. The car dictionary was renamed to self, and because we're trying to get a key, we're going to remove that, and we're going to just use a dot. Now, if I go ahead and take all of the code before, we can take these cars and instead just do car, Ford, pickup truck, 1998. And then I can delete the dictionary. I was just keeping the dictionary so that way I could see what I had typed before. Someone give me 2 other cars. I don't like these 2 examples. Go ahead. Someone pitch me another car brand. I don't know anything about cars, so I'm relying on you guys here. Come on, guys. I need you. Acura MDX. I see Acura, and I see Mercedes. The only car I know from Mercedes is the Mercedes-Benz, which I believe is your stereotypical car. What is a Acura MDX? What is that? I don't know cars either. I picked a horrible start, didn't I? Don't worry, I'm going to pick something next that is a bit more friendly. Something I think you guys... A Tesla. Someone gave me a Tesla. I actually like a Tesla. The Acura MDX looks to be an SUV. I'm gonna do an SUV. I'm gonna assume that's what it is. Also, I just realized I typed car. Okay, so now I have 3 cars, and all I have to do is I can simply say car.honk, car2.honk, and car3.honk. Now you guys are probably noticing to pass in car here. Well, that's because I'm saying car.honk. And because I'm saying car.honk, it's actually realizing that, okay, well, clearly car is what I want. That is my self dictionary. So I'm just going to assume that car is self. Same thing here. I never pass in a self dictionary. Notice how I didn't do self Ford pickup truck, SUV, car, etc., etc. I don't need to. It's assuming that the variable is self, and it's doing it automatically for us. So if I do this, this should print the exact same. Yep. Ford pickup truck says honk. Acura SUV says honk. Mercedes car says honk. Now, that's really cool, but now we have even more power, because now we have access to Python's pre-made class methods. Let's say I want to define the string function for a car. Do you guys know that what happens when you call print? Print of car actually does basically the following. System.output.print string car plus \n. That's abstractly... Your screen is blurred. Oh. Give it a second. That's all I can recommend. YouTube is really not having a good time with me right now. But I'm going to continue on as if it's okay. I understand that it might suck, but there's not much I can do, sadly, at the current moment. Chat box, because it doesn't look like it's working anyways. Try and get less things on the screen, who knows. So what print does is it actually calls string on the object, it appends a new line to the end of that string, and throws it to system output. Zoom in. Can you increase the quality? I can't. I mean, you on your end probably could, but I cannot. Same thing happened to me, so I'm going into quality settings and change it. Yeah, YouTube may have thought that you need to change it, may not. I'm just going to give you guys a second to do what you need to do. Camera wants me to zoom in, so I'm zooming in. I was on 140p! Oh! Okay, so it's not my fault. Alright. Cameron did ask me to zoom in, so I zoomed in. If you guys don't like this, I will zoom back out. That's your call. Anyways, I want to talk more about string. So, what happens if I want to just call print car? Because remember, it was that dictionary type thing. I want an actual string. Well, what I can do is I can redefine the string function to actually return a string. So what I'm going to do is I'm going to say, when I go to print a car, here's what I want it to do. I want it to take all three variables, self.brand, self.model, and self.year. Cameron, you just sent me a text and I read it on my watch, and I hate him. So you can define self.brand, self.model, self.year, and now when I go to print my cars, you can see it doesn't print out some gobbledygook. Here's what it happens, though, if I don't redefine string. So doing the exact same code before and after. Notice how, when I'm not redefining string, it is completely unlegible. You have no idea what the hell it's supposed to be other than a car object and where it's located in the memory. That's not helpful to us. With this, I can overwrite what Python does automatically. So there's string. What are some other ones? Well, let's ask this. Have you ever wanted to add cars together? Yeah. So, how do we do addition? Let's bring up Google. And what I'm going to do is I'm going to let's add my Chrome. Yeah, it's telling me you guys are not having a smooth time. I don't care. I do care. It sucks that you guys aren't having a smooth time watching this. However, I do need to actually go through it. So, recommendation, watch the video afterwards. It will be a video. I'm going to Google Python class add, because that's what I want to do. And I'm just going to simply Stack Overflow. I like Stack Overflow. And so he gives a quick overview. Add takes in self and some other B and only works like this. So if you want to do multiple adds, you sadly can't do that. However, that's not what I want. I just care that add is apparently a thing, so that's what I'm going to do. So I'm going to remember this time to get rid of my Google Chrome. You guys must be so proud. And I'm going to code adding cars. So it takes in, of course, self, but now it takes in some other, and I'm going to assume other is a car. You can check if other is a car using isInstance. If we take a look, isInstance takes in a object and the type you want. So I can check if other is instance of car. So I could do if not other is instance of car, return car, and we'll just return a Ford pickup truck from 1965 by default. And if it is a car, what I'm going to do is I'm going to return another new car. However, what I'm going to do is I'm going to add in some funkiness to it. Self.year, other.year. So what I'm going to do is I'm going to take the brand of car A and the brand of car B, and I'm going to smush them into one word. And I'm going to do the same with the models. And I should use a space. This is why I like F strings. They are designed for this type of problem. I'm going to smush them into one string and create a brand new car with both of the information, and I'm going to say the year is the earliest year. So whether it's self.year or other.year. And what I'm going to do is I'm now going to say print car plus car2. So remember, it still prints. However, now I'm actually adding them together. And when I add them together, it's the Ford Acura pickup truck SUV from 1998. Yes, I'm going to say there's a Mercedes from 1658. So although 1998 is the smaller year for car 2 and car 1, car 3 has the smallest year, and hence why it would be 1658. This isn't hard conceptually, but it's a little intimidating at first. You just got to remember that every object is essentially a dictionary of information. All of those questions where you were working on dictionaries, everything here still applies. It's just now you get nice little functions. So, with all this being said, I'm not going to teach inheritance just today. I don't know if any of this, but it kind of seems like adding or defining addition for equivalence classes. Yeah. That would actually be a pretty accurate comparison. What happens though if I do car plus 5? Because remember, I check if they're both cars. Returns a Ford pickup truck from 1965. Can you explain how add works? Yeah. Cameron wants me to cover inheritance, but I'll only cover inheritance if you guys want me to cover inheritance. First, someone asked if I could explain how add works. And if you think about it, this is the easiest way to understand it. Python automatically converts everything into a class notation. Python, as mentioned at the beginning of this tutorial by a student, everything is a class. Files, classes. Exceptions, classes. Everything is a class. So these operators, like plus, minus, multiplication, everything is a class. And there are even little funkies. So if I do A times B, you could say that that is you could say that that is A mul B, or you could say that that is B R mul A. R mul stands for right multiplication. It is on the right side of the multiplication, and it's multiplying backwards with the item on the left side. You guys will need to know both mul and R mul for assignment 8. You guys will need to know add for assignment 8. You guys will need to know string for assignment 8. These all automatically convert into Python class notations. String of A becomes A dot underscore underscore string underscore underscore. Those underscores mean that it's built into Python and it's private. So if I actually called A dot underscore string underscore underscore, that won't return anything. It's something that I as a programmer can't call, but it's something I as a programmer can code. Can we do some sample problems? Yes! Of course we can do some sample problems. Give me anything. Give me any concept. What do we need to know for A7? A7 is all about reading code and identifying problems. It's all try and accept. That's really what A7 is. A7 is just rigorous try and accepts. So go ahead. Someone give me a problem. I want to see why this is useful. What? I need an object that I can actually describe how this is useful. Because in this code, it's really hard to understand the use of something before you actually just hop in and do it. One of my favorite examples is the human race. The human race, if you think about it, you can define a class of a human. Let's say, what's something that all humans have in common? We all have an age. Not everyone has a name. That's not something we can assume. We all have an age. We all have a height. Oh, dog breeds. Dog breeds are another good one. Okay, let's do dog breeds. Dog. Let's do dog. No. Natural numbers. That's funny. I could definitely do that, but let's do dog breeds. Okay, what do dogs have? Go ahead, pitch me things. Eye colors. All dogs would have eye colors. That is something that all dogs would have. Anything else? I want at least one more. So instead of height, I'm going to say weight, because maybe fur color. I'll allow it, but not all dogs have fur, and we'll account for that. Okay, I'm gonna call it there. We're gonna deal with breed in a different thing. So we're not gonna assume that a dog has a breed, because I want to teach you guys inheritance. Cameron brought it up, and yeah, I wanna teach inheritance. So we're gonna assume that dogs have an age, a weight, an eye color, and a fur color. And fur color is going to be allowed to be none. So what I'm going to do is I'm going to simply define the dog. So self.age, self.weight, self.eye color, self.fur color. So now we have an abstraction. Gender, tail length, not all dogs have tails. Snoot boopness, that is quite the metric. We're going to say, instead, we're going to have boopness be a function of a dog. All dogs will have a... Nick did it with the Weasley family, I see. We're going to say that all dogs have a boopness scale in which is calculated based off the dog. So, first thing, smaller dogs that weigh less, are going to be more boopable than larger dogs. I'm going to say that that's going to be our general rule. This isn't true in my opinion. I think that big dogs are more boopable, honestly. But we're going to say that boopness is going to be something for large or smaller dogs, just because we can. So by default, we'll say that boopness equals 100. Then what we're going to do is we're going to say that boopness is going to subtract the self.weight. However, what happens if he weighs more than 100? So I'm going to pick the maximum value between, let's say, 20. All dogs are boopable. It will be either minus 20 or minus self.weight. And it picks the minimum value of that. What else defines whether a dog is boopable? For example, someone give me something like, do you prefer to boop old dogs or young dogs? I personally prefer young dogs, so I'm going to do same thing. Dogs don't typically live past the age of 10, as far as I'm aware, so I like younger dogs, but if a dog somehow manages to live past 10, we're going to subtract boopness. And then what I'm going to do is we're going to run a if statement for if self.color, fur color, boop all dogs. I agree, you boop all dogs, but how big to snoot? That's a good factor. Sadly, I'm not accounting for it. If fur color, so if there is no fur, I'm immediately going to say that boopness minus equals like 50. That's a big thing for me. I like booping dogs with big fluffy coats of fur. Next, I've always been partial to black dogs. I love black dogs. So I'm going to say that boopness is only equal, or Boopness will go up. Boopness goes up by 5 if the dog is black. In all other situations, boopness will be divided by the length of the fur color. Let's say that. I know it's harsh, but this is just some sort of ambiguous number. So this is cool because it defines dogs, but it doesn't define specific dogs. So yeah, I can say that dog, my dog Toby, he was 6 years old. He was a big boy. He weighed like 20 kilograms, so we'll assume that's kilograms. No, not 20 kilograms. He was a big boy, but he wasn't that big. He was like 16 kilograms. Either way, he had brown eyes. It was really adorable. And he sadly was a golden. He was a golden retriever. However, golden doesn't really, like, this is a dog, but it's not a dog. Because you know that there are huskies, there are poodles, there are many different breeds. So let's say now I want to create my favorite dog breed, husky. Do I want to redo absolutely all of this? And yes, Karen brings up a good point. I need to return boopness. Do you want to redo all of this code for a husky? No! Why would you want to redo all of this code? You've represented a dog. You now have functions on a dog. You can work with dogs. It's helpful if you're a veterinarian. If you want to add dogs to a database, you might as well just make a dog class that contains everything about the dog and just store that dog class. But you don't want to keep recoding. So what we're going to do is we're going to say huskies inherit dogs. They are dogs. So now what I can do is in self, I now know that my husky has a breed. Huskies are worth it. Yeah, they are worth it in my opinion. So huskies are still going to take in all of the same information that dogs do. Samoyeds are a really good race. I completely agree that, but huskies are great. I've always been partial to huskies. Huskies, golden retrievers, malamutes, like just big hairy dogs. It's always been weird. And my favorite small dog is a beagle. I don't know why. So what I'm going to do is I'm going to say that now I have a breed. My breed is husky. However, I'm not going to say self.age equals it. I'm not doing that. That's a lot of variables. Instead, I'm going to use something called super. What super does is it actually calls this dog class, line 32, missing after self. I don't have 32 lines, so I don't see what you mean, Cam. There is no line 32. Why do you hate me? I'm going to assume that this is working. Thank you for using Cameron Lint. You're not helpful. I see it. I see it now. Missing comma after self. Line 23. Cameron. No. So what I'm going to do is I'm going to take in all of this information, and I'm just going to pass it into super. I'm going to ask dog to build me a dog and then shove that dog inside the husky class. A comma is missing in line 23. That's what Karen was trying to say. He failed at it, but... Now, I'm trying to remember if I have to pass in self. I think I have to pass in self as well. Why any of this is useful? Well, first let me finish. I want to define boopness, and I'm going to simply say super.boopness of self. I'm gonna simply end it here because the calculation for the boopness of a husky doesn't change. However, what if I want to say, because I'm biased, they get a plus 10 no matter what? I can do that. So I get how this works, but why is any of it useful? At the end of the day, you will need to code certain things. If I'm going to go on a bit of a personal tangent. I'm going to show you guys some of my own personal work. Colon missing. Yeah, I'll let you guys fix it, but that was just to show off inheritance. I'm going to show you guys some of the stuff I've worked on and why I've chosen to use object-oriented and use classes instead of using functional programming. How many people in this chat currently watching the YouTube video have played Bloons Tower Defense? I just want to see, like, Super is your parent class. So Husky inherited Dog. So Dog is what is Super. You can think of it like that. Whatever you passed into the class. So for exceptions, Fire Exception inherits Exception. Super is then Exception. It's the exact same word. Thank you, Karen. But how many people in this chat have played Bloons Tower Defense 6? I want to see just how many people. Cameron, I know you've played it. We played it together. I want to see if more people have ever played a tower defense game. Let me ask this. I haven't. Great game. Yeah. Do you think that every single tower in Bloons Tower Defense is a brand new variable with a brand new definition every single time? So when I place 2 dart monkeys, do you think the coder goes through all 13 lines that it takes to define a dart monkey every single time, and then defines universal functions that don't apply to any other monkey just for the dart monkey? No. What they do is they use object-oriented. So I created a bot that takes in a game of Bloons Tower Defense and automatically plays it for you. Me and Cameron being Bowsy Pup, he helped me with this. And whoops, I don't want to show you game. I want to show you tower. So ignore the imports because it doesn't really matter. But if you look, my class of tower takes in whatever hotkey you need to place the monkey, maybe an image of the monkey, some configuration stuff, and a name. And what it does is it creates a monkey, gives it the name, it gives it the upgrade path. There are 0 upgrades anywhere. It places it somewhere on the screen, stuff like that. I can print it. I can print certain text. I can add in funky designs to it. I can get the position of that specific dart monkey. The code is a mess. Yeah, the code very much is a mess. Comma after cell. Well, the code. Me and Cameron did this quite a while ago, so it's not the best. But like, I can get the position of the dart monkey. I can place the dart monkey. I can select the dart monkey. I can deselect the dart monkey. I can upgrade the dart monkey. I can upgrade it certain amount of times. Yusuf, I think you're a little far behind. But all of these are classes that are done on a actual instance of a tower. When coding a very object-designed game, it is helpful to define everything as an object. If they all have the same things in common, then the code will go a lot smoother. Because if I show you guys the Dark Castle map, literally, Oben equals a tower. Dart Monkey equals a tower. The sub equals a tower. The delay is awful. Yeah, I'm mad at YouTube and I'm mad at my internet. So, but like everything becomes a tower, and they all share the same properties. But notice how I didn't have to define the functions more than once. I didn't have to account for variations on the towers, and I am now using one line to define an instance of my tower. This is this is 67 lines just because I chose to go out of my way to define a tower game and console class to reduce the lines of code. I don't know if that helps you understand why object-oriented is helpful or not, but like it's very much you want to reduce how often you copy code. And at the end of the day, if you're going to build something in which could potentially hold 1 to infinite instances of the exact same thing, why not use a class? And some things are just designed to be classes. My favorite example, and this is one that we are going to be doing in class, or in tutorial, the binary tree. This was designed very much to be a class. If you look at it, you have a class of nodes, and each node has a value, a left, and a right. So in 40's left, there's 4. In 4's right, there's 34. In 34's left, there are 14. In 14's left, there's 13. And in 14's right, there's 15. This was designed to use the node class. So it's really helpful to use object-oriented programming. And if I wanted to use binary trees, I could then code functions on the binary trees. So I could say node.add, and I could say add 10. So how would I add 10? 40 would call .add. It sees it has no available children and says, okay, 10, go on my left side. 4 says, hey, I have an available child, but only things smaller than me get to go on my left. So 10, I need you to go on the right side. I'll cover binary trees more in depth next week, because I think that's the tutorial topic for next week, but I'm giving you a quick glimpse. 34 then says, hey, 10. Sadly, you're smaller than me. I need you to go on this side. 14 says go left. 13 then says, hey, 10, I can take you. Become my left child. Some things are just designed to be classes. And at the end of the day, it is down to the coder to decide what they want to make a class and what doesn't need to be a class. I don't know if this really helps you understand the value of object-oriented, Haley, but that's the general gist of it. It is a code repetition fixer. And it's helpful when you're designing a real-life object in which you want an instance of. If I have 1 Coke Zero here, and I want 4 more Coke Zeros, I could make them all the same class, but with slight differences, right? And at the end of the day, if you genuinely are like, well, we could just use dictionaries and we could just use universal functions, that's up to you in most cases. So a lot of courses will force you to use object-oriented, and there are some languages which force you to use object-oriented. Yeah, I highly recommend actually using some genuine practice. If it weren't considered academic dishonesty, I would show you guys my 2040. Actually, I can show you guys my 2048. No, it's for an assignment. It would be considered academic dishonesty technically. But I can explain 2048 real quick because I have 2 minutes. Whoop. 2048. If you've ever played, this course moves ridiculously fast. This course doesn't move fast. This course moves at a bad pace. object-oriented programming is something that we should have introduced a long time ago. Arguably, we should have introduced the concept before files and before anything else. Like, not maybe before defining a function and recursion and stuff like that, but like right after recursion, I felt object-oriented should have been there. Yeah, 2048. It's a great instance of maybe a class of two-dimensional arrays. However, if you actually look at the source code, 2048 is object-oriented. Every single one of these tiles that you see is a class. Every single movement I'm making is me calling a function on the board class. Everything I'm doing is manipulating objects. Now, of course, this is optional. I've coded 2048 without using object-oriented, but this is the way that they did it. And I genuinely recommend it. Really inefficiently. Is it? Is it inefficient, though? I say that it's a lot more human readable to say everything is a class, and efficiency can be dealt with. ASCII 2048. I coded in ASCII 2048. Thank you. You've got to make trade-offs. If you're going to code 2048, you're gonna, if you want to do it without objects, then yeah, you can use matrix rotations. You could move everything right and everything left. But at the end of the day, the trade-offs are things that you're going to have to make. You're going to have to determine whether or not they're worth it. One of my favorite debates is object-oriented worth it if you're working on a project for a long time? The entire point of object-oriented is to cut down on code repetition and to make sure that the code is extremely readable and understandable to a human. So, if you're going to be working on a project for 2-3 months, I genuinely consider that using object-oriented programming is the better choice. Just something for you guys to consider. Every code paradigm has its place, even functional programming. You just have to find what you like. Anyways, I'm out of time. I will gladly hold more of these debates with you guys outside of office hours. The only thing I had to do was teach you guys how to do basic object-oriented. I know I rushed inheritance, but that's because you're not going to see a lot of inheritance in this course, and inheritance is one of those things where there are better examples than what I did. Inheritance, schmanks. There are much better advantages, and there are much better examples, and I'm only one guy with a very loose lessons plan, and I had to make sure that you guys understood the basics without getting overwhelmed. And I feel like me showing you guys how dictionaries and objects have such a close relation, and how to do an object without defining a class, I feel like that could genuinely help for you. Either way, I recommend looking into it a bit more on your own time. Yeah, I'm gonna head out. I realize the delay is absolutely horrible. I am going to be changing my streams like ultra low latency. Bullshit. But yeah, I'm gonna head on out. I'm gonna let you guys get to your next classes. If you want to come see me in office hours, we can talk about anything you like. The thing I like about office hours is I actually get to have a rapport with students. And it's live. You talk to me, I talk to you. You talk to me, I talk to you. So hopefully in office hours I can alleviate some of the confusions that this tutorial couldn't. And maybe if I find more time... Call me. Okay. Maybe if I find more time, I will maybe post another tutorial that goes a bit more into some of the use cases. So yeah, Be on your merry way, children.